Okay, so let's start for today. So last day we discussed on linear regression. So there the funda was quite simple, that there should be a linear relation between the independent and the dependent variable, and on basis of which we draw a linear line which best fits and predicts about the predictor or the independent variable, sorry, the dependent variable, the response variable which we want to uh, calculate. So logistic regression is just an extension of linear regression. So what happens is in linear regression we have a line scale which can vary from minus infinity to plus infinity. It has a wide range. But in logistic regression we need answer in binary. It can be either yes or no. So there can be only two possibilities, 0 or 1. Answer in binary. So in that case, linear regression won't be a good method to make a binary classification. And also at the same time, suppose I have a linear line which goes from down to up, and this is the threshold line. So I can say that anything above this line can be taken as a true or a yes, and anything below this can be taken as a no. I can make such kind of a linear line, but that won't be appropriate and it won't suit all the situations. That's why we come up with a uh, condition of or method of logistic regression when I can have a steep rise. Or suppose for this level I can have my value near to low, and then it will take a steep turn, and it will then be uh, around a flat line or a constant line somewhere like this. So a S type of uh, curve which resembles somewhat like S, somewhat like this, not as uh, smooth curve or a like a but a kind of this, it goes till here straight up and then flat line. So we need such kind of uh, a graph or a representation through which we can understand that where we can have a better probability to have a yes or no, and based on that probability value that we get from logistic regression we make a threshold and understand that whether what are the chances of having a yes or no. So let us start with today's session and try to understand that how logistic regression works. So as I said earlier, it is basically a method to classify between binary, my yes or no. And linear regression is not suitable for all the methods, so that's why we come up with a logit function. And what is a logit function, how it works, it is quite similar. So what happens is in a probability value I know that my probability will vary from 0 to 1, and that is the only case. Probability value cannot be negative. And I know that in linear regression my regression line values can vary from minus infinity to plus infinity. That can be the entire range. So what I have to do is I have to scale up my probability from 0 to 1 to minus infinity to plus infinity. And for doing that, instead of using probability, I use odds of probability. So what is it? M- My p value will probability value will be from 0 to 1, and odds will value from 0 to infinity. And if I put a log on this, then it will vary from minus infinity to plus infinity. So minus sign is here, so don't confuse with that. So it will vary from minus infinity to plus infinity. So this is what is my logic function it will do. It will scale it up. Where I was having my probability from 0 to 1, it has scaled it up to minus infinity to plus infinity. And that is why we use this logit function, and hence the entire process is a logistic regression. So, for example, take this as a case study and try to understand that uh, suppose I have a condition whether a person will buy a product or not. So, for 1 it is yes, and for 0 it is no. And along with the age, I can see that with lesser age, a person is less likely to buy, and people who are older are more likely to buy. So here if I draw a linear line, I don't think it will suit or it will serve the purpose. I need something like this. So here it will go like this. It will take a steep curve, and then for all the greater values of age, I should get my higher probabilities. So see, the challenge with the linear regression line is it won't fit. I cannot make any sense out of this. So I have to get a function or something curve which will make a better understanding of the situation, which can comprehend it better or which can provide a better solution. So for that, I've come up with this logit function. And using this logit function, I get a graph like this. And this explains better. So suppose I have made a threshold of probability somewhere here. So any value less than this will be my no, and any value more than this of probability will be my yes. So this is how it will help me to classify that what are the chances, what are the odds, or how likely a person to buy a product or how likely, unlikely he is to buy. So here I have only one variable in logistic regression. Unlike linear regression, we can have multiple variable as well. So I need to take care about that and need to understand that how multiple factors might affect my situation. So a few days back, if you remember, Sashi shared a case study on Titanic, and that was, I think, on logistic regression, if I'm correct. Is it right, Sashi?
Yes, Ankit.
Yeah. So in that data set, if you check that, there are many variables like age of the passenger, his gender, and what class he's traveling with. So these are the factors which will determine that with how likely is that person to survive in case of that accident that happened in Titanic. If such is the case, then what is the estimation or what how likely a person is to survive that situation? So all these parameters were used and to come out with the result, or mainly we come out with the probability value, and that helps us to understand how likely. And then we choose a threshold value, and after that we consider that uh, what are the chances. So so if you remember in last class, there was a simple linear regression for simple linear regression where only one variable is there, one independent variable. I have something like this. My expression or my equation is only the top part that is above the exponential. Okay, and in case of multiple regression, my equation is something like this. So all it has done is the probability of happening versus not happening. So what is this is probability how likely it is and probably how unlikely it is. So it is the ratio of these two and log of this, and that comes out to be my linear model or the regression line that I've created. So any doubt till here or any challenges in understanding? So this is the only thing that you need to be clear about. If you know understand this, then things will be clear in logistic regression. Okay. So, okay. So let me move ahead. So last day, as you have remembered, for estimating the values of coefficient beta that we have here, we used minimum least square error. So after taking that error value uh, or summing up the square of the error value at a point or at a value of beta for which we are getting the least error, we choose that as a beta value. But here the case is not as simple. So what happens is here it is to the power of exponential. So that is the challenge here. And for that reason, this same least fitted square error doesn't work much. So here we come up with another method to estimate the values of coefficient, that is my maximum likelihood estimation. So this is very important from interview point of view. When you go for an interview, you will ask that what there is a method that is used for linear regression, and what is the difference for that in logistic regression. So this is the main method of estimating the coefficient, that maximum likelihood estimation, using which we understand that what would be my value of width, that coefficients, several coefficients that I have, or the slope associated with a variable. So we don't have that straightforward analytical method to estimate the value like we had in linear regression. So what we have it, we start with a most close value, or most suitable value, which would be uh, quite likely to have, and we put it into an iterative state where it start improving itself. And at a point of convergence, what happens is, so if I try to understand with a simple example, so let understand that you have a curve like this. Suppose by rough estimate, I have chosen a point somewhere here. So this, but this point doesn't make my errors to be minima. So what happened is, I will try to uh, estimate some other value. It will be an iterative process, so it will try to come up with the next value. So there is a factor alpha, so that mathematical equation is quite higher, and that there is a uh, technique of gradient descent. So what happened is, if this slope is somewhere like this, not equal to 0, so it will keep moving some other value ahead, a small value alpha. So it will move ahead, move ahead, move ahead until it gets a value of constant slope, somewhere like this. And suppose it has gone up, it will again try to move down with a small value alpha. So until and unless there is a convergence, after which neither it can go up or down, it has reached a convergence point. At that point, we make it that this would be the suitable value for my beta. So this is a, you know uh, a way to explain you that how that coefficient is estimated. So as I have mentioned here, so this process begins with a tentative solution, revises slightly to see how it can be improved, and it repeats until improvement is minute, or there is no improvement at all. So like I said, when it has reached the slope or the most bottom point, there can the dy by dt or dy by dx will be almost equal to 0. So when there is no scope of improvement, at that time it will become stagnant, and that point will be taken as my uh, for considered for the value of beta. For some, but there is a case that for some instant the model might not reach a convergence. That would be the case. Then I need to reconsider my variables that I have taken so far. It could be possible that my coefficients are not meaningful because the iterative process is unable to find an appropriate solution. And failures to converge may occur due to many reasons. There could be, like for example, the predictor number of predictor variables are quite high. Multicollinearity is also a case here in logistic regression, so need to take care of that because as you said, the logit function is equal to a linear uh, sign. So here I need to take care of multicollinearity as well, and there could be some several other methods or reasons as well. But mainly, if you have chosen your variables well, then it is quite likely that all your values will converge. So If you remember last day in linear regression, we used to check the p-value using the t-distribution because the beta coefficient in the linear regression followed a t-distribution, and using which we had a p-value, corresponding p-value for that t-test. But here in logistic regression, for that beta coefficient, we have a chi-square distribution. So when I will do a logistic regression today, so we will see that there is also a similar table like we had yesterday, but only thing is that it is the p-value there is based on the chi-square distribution. So again, like the previous day, and there was a test for beta test for uh, linear regression. A similar test we have here for chi-square test. The null hypothesis being the independent variable has no significant impact. It doesn't impact, and the alternate hypothesis is it has an impact. So similarly, if we get a p-value in the chi-square test as less than 5%, then we reject the null hypothesis and accept the alternate hypothesis that it is making an impact. And things are quite similar. So we will see that. So this is again the understanding of chi-square test and how it is done. And there are a few checks that we need to do, final checks for logistic regression. So whether I have my answers in, or is there any requirement for categorical variable like 0 and 1, yes or no, win or loss. So based on this, we will see. Also, like I mentioned, VIF is quite important, or multicollinearity. Should make all attempts to remove multicollinearity so that you know the impact of the same variable keeps getting added up, and your model becomes quite you know over burdened by the same variable. So need to remove that, and also need to see that what is the overall accuracy, which will help us to determine that whether we should move forward with this or not. So let us take a case study for today, and let us try to understand that how we can work with logistic regression. So last in the group, I have already shared the data set with all of you. You can go through it. So today for the first case, I will be taking a data set for death penalty. So let us start with. So here I have my death penalty. So like you say, here are mainly three variables. So this is my response variable, which I need to predict whether the person has been sentenced to death or not. And this is about race. So is that person what race it belonged, whether it was a white or a black. Okay, and this is mainly about the scale or the kind of crime that he has committed. From a scale of 1 to 6, if the person has committed quite a less impactful crime, or I would say a heinous crime, then it will be 1, 2, 3. Or his crime is more severe, then it will be around in the scale of 4, 5, 6. So that has been, so in this way it has been aggregated. So let us make a logistic regression and try to understand that will these two factors influence my death penalty. So same thing, only first four rows we are taking. So now randomly take from row 359 to 362 and see. So same thing. So here I have towards the last, if you can see, uh, that scale of their crime is on the range of 6. So let us try with a logistic regression model. Here in logistic regression, this is my response variable, and these are my independent variable. And family will be binomial because I want my answers in binary, either yes or no. And this is my data. So if I look at the summary, so these two are the two variables and all of them are significant. And if I look at the coefficient of variance, so this was the coefficient there. So that was the of scale A. And here for this it was 4.66. And now with graphically, let us try to understand that how it has been varying. So if I plot just a simple graph, so what I have done is I have so here I have only two variables, and every variable will be having a coefficient associated with it, and on basis of that, by evaluating the coefficient, here I have put them into a for loop and calculating. For black, I have calculated all the parameters or the probability parameters that was associated with it and stored them in a vector. Same thing for the white. And now I'm trying to plot that vector and try to understand then how it would have varied. So here if you see, this line is for white victim and this is for a black victim. So in every case, if you see, the probability of a white victim getting penalized is higher compared to a black victim. So is there any bias between a white or a black? Yes, there is a bias, and to some extent, yeah. So in some cases, the probability is quite high. But when the seriousness of the crime that was committed goes higher, then the probability value starts converging. If you see. So this is mainly how a logistic model is worked, and here I can choose a threshold which will define that if the probability value is above this, then all my values will be yes, and if it is below this, then all my values will be no. So I hope this makes sense and this is clear to you. So any questions here till here? Uh, so least square method, for that also, in the previous class, may have not taken a visualization, but mainly I've discussed the formula, how we derive at it. For uh, MLA, mainly there is a, so what I've come across is a gradient descent. So gradient descent is a very good way to understand that how it works, how it moves to a down the slope and gets to an optimum value. Like I have discussed that in a graph just now. So that, and also with MLA, I've also shared a post in the classroom. So that is there in the analytics with their link. You can go through it as well. So there they have in detail they have discussed about gradient descent and MLA. MLA not quite in detail, but yeah, but about gradient descent they have quite uh, largely elaborated that how it works. So mainly the concept here is same. So any other questions or should I proceed? Okay. Even that is a good question. That in case if I have my predictor variable as categorical or not. So in that case, mainly what we have done is make a categorical variable as dummy variable for if number of levels are n, then n minus 1 dummy variables I need to create. So there are few examples in which I will discuss that. So let me go through that. And orders for which, no, I don't think that order matters. All it matters is it making a contribution or not? No, 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 that doesn't matter. See, what happens is if suppose my gender is male and I flag them as one, so automatically other part will be zero or the female will be zero. Okay, so I don't need to create another separate, uh, I would say, uh, variable for that. So that will be like a mirror image. So even if whatever you take, either take male as 0 or 1, it is up to you. The other part, the counterpart, will be the opposite. So this is the main assumption. So whatever you take, that is completely okay. So let's say if I have four directions, north, south, east, west, and for that I need to create three dummy variables. So order could be anyone. I can exclude anyone. Suppose I have excluded west and flagged only rest of the three, or suppose I have excluded north and included rest of the three. So I can do it at any way, and there is no such compulsion that I have to make it a particular order. So loan acceptance, and this is mainly used for all the loan acceptance, and for that loan default I've worked with a lot of logistic regression. Let us see what is there in this. So here I have ID, I have age, experience, income, zip code, so and so, and credit card, personal loan. So these are all categorical variables that I have. Credit, yes or no. So let us go through this and try to understand that what are there and how well we can make a prediction here. So here I have all the age, and age is, as you can see, is not like a normal. So it is more of like a straight line, a uniform distribution. Experience also somewhat like that. Income, so bit skewed towards right. Family is a discrete one, so we need to make it as a categorical or treat as categorical. Mortgage, so mainly frequency, so most of them don't have a mortgage. Seems like security account, yes or no, either in the binary, so most of them don't have. In binary, online also binary. credit card, yes or no, and education also, till what level. So level 1, level 2, level 3. So here, uh, if I see, so I need to predict on my personal loan, yes or no. So if I see here, so most of them don't, and as few of them have a yes. So this mainly doesn't represent much. Actually, uh, main here won't make much of a sense. I think a table will. So here these are the numbers. So if you can see around, uh, the total seems like around 10% is yes only. So here, like Arun you said that, what happens if I have many categorical variables. So here in family size, if you see, so this is my family, and what are the levels that I have here. So here it is mainly 1, 2, 3, 4. So if you see, so this is the distribution for it, 1, 2, 3, 4, and like this. So these are the numbers, and here of the 4 categorical variable I am making three only three dummy variables, and I'm excluding the one. So let us do that. And for education also I have three levels of categorical variable, and I'm making only two. Now putting all the variables that will I think will be required into a single data frame XXX and working on it. So see here I have made only response, which is my personal loan, age, experience, then income, family, so number of family members. So this is also a categorical. This is only 0 and 1, so no need, and all others. So the one which were not there as a categorical variable, I have made them into category and work with them. So now let us split it into a test and train data set. So 60% will be my train, and 40% will be train. Sorry, 60% train, and rest of the 40% as test. So out of 5,000, 3,000 as train. Yeah, test and train. So test will be my 2000 and train will be 3000 in the ratio of 60, 40 60. Test train 40 60. Okay. So what is train and test data set? So what happens is, mm, let me put it in this way. Uh, so once you are building a model, so once you have a data set, what you need to do is, you need to validate your model. So uh, uh, what we do, we take a partition between the data set. It is ideally 60-40, or it could be 70-30 as well. And we partition our data set. And the part with major part of the data set becomes a trained data set when we uh, build our model, train our model, and test it on test data set. So using the first part or the major part of the major proportion of the data set, I will make my logistic regression model using all the observations there. I will fetch it to a model, and it will learn from there that how should be my response if an out of bag sample, if a sample which is coming from outside, how I should treat them, and that we test it on test data set, that how good I perform. Because if I test it on the same train data set, I'm expected to have to have a good result. So it will be quite obvious. So that won't be a good judgment of how my model is behaving. Rather, what I should do is I should test it on a different data set to see if a out of bag sample comes in, then how good is my model. Okay, so that is how to check the strength of the model. So for that reason, we split it into train and test. So where I was, okay. So here, so here if you see some of the variables are not as significant. So age was expected to have a quite a lot of significance, but it is not. Even experience, family only 3 and 4 are making contribution. Two family members are not, and also mortgage. Mortgage is also a binary, but it is not making any contribution, any significant contribution. So anyway, so here let us remove that response and try to do that on a train and test. So the train part I'm putting it into X train, and what is not there in train, that I'm putting into X new. So similar results, age and experience doesn't have any contribution. So let us not remove that and let us work with it, and let us see how good it can predict if I keep all my variables. So right now I'm not working with a variable selection. We will work with that in the next few case studies. So here I am predicting. So try to understand this. I've not much elaborated, but let us try to understand. So response is my personal one, whether 1 or 0, correct? And it
Yeah,
depends.
1 minute, Ankit.
Yeah. Mm-hmm.
So I have one doubt.
Mm-hmm.
Just like yesterday, we have to discuss in suppose that in one data set,
Mm-hmm.
I have a 99 variables.
Mm-hmm.
So in 99 variables, so
Mm-hmm.
cause of that, sometimes this is overfitting.
Mm-hmm.
So that time I use AIC techniques, AIC
Yeah.
function.
Yeah. Yeah.
We have to use. So
Mm-hmm.
finding the which variable is more suitable for particular model.
Mm-hmm.
So in the logistic regression, we are using AIC or not.
Yeah. See, AIC can
And
be.
also what is the null deviation, what is this thing?
Okay. So null deviation is see
Yeah,
null.
suppose I just yeah,
Mhm.
yeah.
So see, AIC can be used for variable selection here in logistic regression as well, and I have prepared some case study on that as well. So we will work with that and try to understand that how AIC works. Null deviance is, so see, there are few things here. One that is caused by intercept, and others that is caused by this number of these variables. So the deviance that is caused by the intercept, that comes as null deviance, and that comes as the rest, what comes from rest of the variables is residual deviance. And even if you see, the number of degree of freedom is difference. Why? Because when I add all of these, that number of variables here, and then I subtract it, then I'm getting it this. So total is my 3000 that I've considered, and one for intercept, then one minus, then it becomes like this. Now if I include all these variables as well, then my degree of freedom goes down. So hope it makes sense that null deviance is for intercept and residual deviance is corresponding to all the variables that I have. So regarding AIC, so I will also take that AIC and we will work with that also. So we can take that in this data set as well. So let us try to predict without excluding any variable, and let us try to do that again with AIC as well. So I was explaining with this equation. So here the response is so a personal loan, yes or no, and on the basis of all the data. So all the responses that are there. So tilde and dot means it will be compared to all the variables that I have. Family binomial means 1 or 0, and data frame. So this will be my data. I have converted into a data frame, and then I'm trying to make a regression on this. And here this predict value. So I'm making a prediction based on my model M2. So M2 is my model, and a new data on which I'm making a prediction is the data frame X new. And what kind of value I want in response. In response means I want in uh, probability. Okay, so I will be getting all the probability values here. So see, most of the probability values is predicting 0, and even we were expecting that because we have seen that most of the values were 0 for personal loan. Most of them were 0. Only 10% was 1. So this plot won't make much of a sense, but yeah, if you see, most of them are concentrated here. So more or less, concentration wise, yeah, it looks good. Let's see how it will work if I make a confusion matrix and try to understand. So here what I am doing is, for any probability value which is greater than 50%, I am making it as my yes. So my threshold value is 50%, 50% value. So let us do that and try to understand. So this is my prediction. So this is what was there. So this is the actual and this is my predicted. So this table is mainly called a confusion matrix. So understand, I'm going it again. This is my uh, original, the actual values, actual 0 and 1s, and these are my predicted. So for how many zeros I have predicted correctly? 1796. And for how many ones I have predicted correctly? This is 128. And what are the misclassification? That is for this. So it was actually 1, but I have predicted as 0. Those are 61. And here it was actually 0, but I have predicted as 1. So that those are 15. Okay. And let me try to calculate what was my percentage error. So it is around 3%. It looks like. So let us say now change it to uh, 7%. Okay. Let me have a better for this. This will help to explain better. Mm. So this is 1 1 and this is 2 2. So 96% accuracy that I'm getting here. So let us try to change the threshold value. So probability of 3% or larger, that will be coded as 1. Now here if I see my error has increased, gone up to 4%. So there is a function or there is a I would say syntax is there, confusion matrix, using which you can make a confusion matrix without making any adjustment with the probabilities value. So it will choose the optimum value and it will give you the same. Otherwise, you have a function to do that. That function will help you to find the correct cutoff value that you need to choose. So like you said, let me do a bit of AIC and then understand that how it should work. So here I had M2. So M2 step 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 AIC M2. Hmm. Okay, so I missed out the package. Where is it? Hmm. So now it has come up with optimum number of variables that I have. So it has excluded all those which were not required, and I've optimized here my variable selection. And now if I look at the summary of AIC, so all of them are making a significant impact. And if you remember, earlier one where we were having 2985 and now it is 2989. So four variables have been removed. So all those which were not required have been omitted out. And now on the basis of this, if I try to make a prediction and try to understand that how my model has behaved, so let us try to do that. So p test 1 I'm putting it as p test 1, m I'm putting it as uh, dot aic. This will be p test 1, p test 1, p test 1, 0.1. Okay. So now let us try to predict using same thing using AIC. So the new model that we have developed using AIC. Let us do that. Again, mainly the histogram. So if I look at it in from the other perspective, plot density p test 1 city. So here I have a big spike. So all the points are mm, concentrated near 0 and few points near 1. Plot again uh, won't make much of a sense. And now let us try to get to confusion matrix and try to understand. So here it should be T11 as well. Okay, sorry. So if you see, here is a slight improvement. So in the previous model, uh, two classification has been meant correctly. So here 15 were misclassified, here 13 are misclassified. Apart from that, everything is same. So not a much big improvement in my uh, you know model, but yeah, bit of relief or bit of a good thing about the results. And also I've loaded my model with less variables, so even that is good. So this final model, we use it p-test 1, here also p-test 1. So this is mainly called my receiver operating characteristics or ROC curve. So ROC curve is mainly a plot between my true positive and true negative or false positive. True positive and false positive. Mainly it can be said that specific sensitivity versus 1 minus specificity. So a good curve would be like this. So suppose if I have a graph like this, straight up, and it goes like this. So where the area under the curve is 1, then that is called a very good lift. And suppose if I am getting somewhat like this only, a poor lift compared to here, then my model is as good as random. So see what happens is if I in a case I have to make a classification. So I'm given two options that either I have to say 0 or 1. So what can happen is my probability of getting the answers right will be 50%. At random, if I do anything, my best or my most probable uh, probability would be to have to get only 50% of the right, because I have to classify only in two. So in case if my model is doing the same, in case if my model is able to predict only 50%, so is it good, or is it behaving as good as a random variable or as a random model? Is it making any significant impact? So for that reason, this ROC curve comes into picture. If it the curve or the lift is near this diagonal line, then my model is as good as random. But here, if I am getting a good lift, then it is making a good contribution or making a good classification. So regarding ROC, I have also prepared some slide. We will go to that and try to understand in details what is ROC and how it works. So let me remove this. So here are few things that you need to know for checking the accuracy of the model. So these are the few terms that you need to true positive. So how many positive I have classified as positive, and true negative is how many negative I have classified as negative. False positive and false negative are my misclassification. So if you can see, the entire case study here is: imagine a study evaluating a new test that screens people for a disease. Each person taking the test either has or does not have the disease. The test outcome can be positive, predicting that the person has the disease, or negative, predicting that the person doesn't have a disease. So there can be two possibilities, whether the person have any problem or he doesn't. So in that case, my classification could go wrong in two ways. For example, the person has a disease, I have classified him as he doesn't. And the person did not have a disease, but I have classified him as yes. So these two can be a misclassification. So here if you see, a true positive is sick people correctly diagnosed as sick. False positive is a healthy person incorrectly identified as sick. So false positive is quite kind of false alarm that I'm getting. True negative is healthy people correctly classified as healthy, and false negative is sick people incorrectly identified as healthy. So my target would be to maximize my true positive and true negative, and minimize my false positive and false negative. So for a model, if I'm getting maximum values here, true positive and true negative, then that will be a good model. So if you check here, the model that we have worked here. So this was like my true positive and true negative, and these are all my misclassification, false positive or false negative. Now specificity and sensitivity. So these are mainly number of all the number of true positives that I have got by number of positives, and total number specificity would be all number of true negatives by number of negatives. So one question to all of you: the case that we have just done. So just try to read this formula and try to tell me that the case study that we have just done and we have created that table, in that what will be the answer. So just here, number of true positive by total positive, number of true negative by total negative. So here just try to tell me what will be my answer. So for your convenience, I'm saying this is my true positive and this is my true negative. So please try. So that shouldn't take much time. Uh, okay, good Arun. So yeah, this is my true or my actual value, and these are my predicted value. So first one will be 1798 divided by my 17. 98 plus 30. Correct. And second will be my 28 divided by 61 plus 28. Sorry. So hope it makes sense now. So this is how it is. A good pictorial representation of my sensitivity and specificity. And this is my receiver operating characteristics. So if I have specificity, sorry, true positive, that will be my uh, specificity, I think. Mm, no, sorry, sensitivity. So this will be my sensitivity, and this will be my 1 minus specificity because it was there true negative. So uh, false positive would be 1 minus of that. So specificity, sorry, sensitivity versus this 1 minus specificity. So let us go to some other case study and try to understand. So here I have German credit model. So here are these code words that needs to be flagged properly. So this A11, A212, these all have some meanings, and for that I have created a particular, I would say, format which will classify them properly. So the data dictionary is not there, but once you go through the code, you will try to understand that what is happening here. So what happened is most of the codes that you have seen are actually factors, and these factors needs to be classified properly. For example, here in credit history, if you see history part, so these are coded like A34, A32, like that, and the meaning for here is levels are A30, 31, 32, like till 34, and the meaning for that is A30 goes for good, 31 good, 32 then poor, 33 poor, and 34 is terrible. So these are the kind of classification that is there. So for that I have created an equivalent code so that will classify it properly and it will label it. So let us do that and proceed. Now if you look at the credit now, so it is like this. So mainly we want to predict whether the person will default or not. What is the duration of the loan amount, other, so and what is the history and so on and so forth. So here are mainly my classification of variables that I have, how many have defaulted, how many have not, uh, all other numeric variables, and how well they have been segregated or have been classified. So let us do a model matrix. So model matrix, what it will do is it will create a dummy variable for all of them. So for example, what we were doing till now, that we were creating a dummy variable of our own by writing each line of code. Model dot matrix will make it of its own. So it doesn't require any manual working of or manual creation of dummy variables. It will create of its own, and we will just have to put that in the model and work with that. So now if you see, I have my duration. So I've excluded my first variable, that is default, and I have started with duration only. Duration, I have amount, installment, age, history poor. So it is flagging them. History is, if it is poor, then 0 or 1. History terrible, 0 or 1. Purpose, and this is I think so purpose used car 0 or not. Purpose purpose goods and repair or not. So like that. And foreign man or not, rent true or not. So this is a good way. If I have lot many variable, then model.matrix is a very good way to work with and to create a dummy variable for each one of them. Now splitting it into a train and test data set. So here is my model that has been created. A few of the variables are quite less significant, like purpose, education, that doesn't make an impact on the loan default, and also age. Age has is pretty less significant compared to other variables. So let us keep it as it is. Uh, we won't make a change, and let us try to predict on the basis of the model that we just created. So for all the values, correspondingly we have got a probability. So for all the default values, default 1 or 0, we got a corresponding probability value, and let on the basis of that try to predict. So here one thing. So here what I've done is I've not taken the threshold to be 50%. I've taken a different threshold. I have used a probability value of 1 by 6 because it is seen that for German credit risk there is a chances of defaulting, or the proportion is quite less. So for that reason I have kept my threshold different from 50%. Let us try to predict on that. So here error is quite high. So around 47% is error. And how much I have predicted correctly? So just the opposite. So in a way you can say that a kind of poor classification that we have got here. Mm. So, and there is just some scope to improve our model and to uh, make some transformation and make a better prediction. Or what we can do is, so we can vary the threshold and see where we are getting a better threshold value that we should choose. So, as a case study, you can work on this. I have not made a much in-depth analysis in this. You can try this as well. The next case study that I will be taking, for that I have worked from end to end, and this was one of the case study that I have got when I was, you know, I was asked to solve this case study, and there it was when I was asked to provide an end-to-end solution that what could be a better way we can work on this. So here I've applied all the techniques so far. So let us go through it and try to understand. So when I applied for one of the uh, uh, startups, they actually asked me to work on this case study and provide a linear logistic regression model and how we should work with it. So first of all, I went through this data set and tried to understand that what we can do about it and how well we can solve. So as you can see here, I need to predict that how likely is that person to vote for a particular party or not. So party voted for here is 0 and 1. So classification is in that regard. And all other things, it seems like it is a factor variable. And I need to convert it into a dummy variable and then I need to work on that. So this is about understanding of the data and let us work with it. So all of them are integer and I know that not all will be integer. I have to work with few of them as a factor. So I'm converting the one which are required to be as factor. So number of children ever born to a woman. So this is either starting from 0 to 16. And if I look at the table, what are the numbers? So here it is. Then I try to make a plot and try to understand that so for most of them it is closer to 0, the number of child ever born, and above 10 is quite less likely. And does voting impact? So this is for party voted, 0 or 1, and how many children that were ever born. So does that makes any significant impact on the decision on voting? So for that I created this table and tried to understand that. So um, if you can see here, if and there was never a child born to that woman, then she is more likely to vote for, not vote for that party, and very less likely to vote for. The trend is similar for less number of child, but then there is a reverse. So and trend has and there is a complete paradigm shift here. So this is a way you can understand that if it has any impact or not. So I thought that this will make a impact. And overall, if I say, so it is like a 50-50 type of distribution. Or let's say not even 50-50, then uh, somewhat I can say 40 to 56 like that. But if I consider from here, there is a complete partial or bias between the trend in which voters were voting. So even if considering this as the standard ratio, I should have expected that to be applicable here as well, but I'm not getting the same trend. So it thus says that there is a bit of bias when a person is voting, and also it depends upon the number of children that that woman has. So this was mainly on age of the women, age of the wife. So I did not see. Hello. So you are still facing that problem, or
No, only wife inclusive loan.
okay? So
Otherwise, everything's fine.
okay. So is it still the problem, or is it now okay?
No, it's okay.
Okay. Okay. So let us now work with a logistic regression model, considering all the variables, and let us try to understand. So considering all the variables, so here you can see logistic regression has created dummy variables of its own. So as I have shown you earlier, wife education was of 4 levels, 1, 2, 3, 4, and it has created dummy variables itself. But what happens is when I need to exclude one of the dummy variables, I cannot do that. That will be the constraint. So for that reason, it is always suggested to you that you make a dummy variable, because in case if it is not required to include that variable, you can quite easily remove that. But here, if I exclude wife education entirely, all these 3 variables will be gone. But I need to exclude only one. So that will be the challenge with me. So that is why it is always suggested to work with model.matrix or make dummy variables. So let me work with AIC and let me check what good can be done here. A few of the variables doesn't make us any sense at all, so they will be removed automatically. So let's see. So I am left with only, yeah, correct. So uh, now if you can see, most of the variables have been removed, and I'm left with only few variables. So this is why AIC is such a good thing to work with when you have lot many variables and you need to finalize only on specific one. You can work with it. So let us check the summary of this. Step. So there are few variables which, like for example, wife education, second flag, it still doesn't make any contribution. In previous model also it wasn't significant either. And also here if I see, so only challenge is that if I have not made it a flag, or I have not made a dummy variable, I cannot remove that entirely, so it will be included. So standard of living index 2 and 3 are not at all required for me. I can work only with 4, but as I have not made it into a split it into flag variables, I have to work with all of them. So let us now work with it and try to predict the response. So response is mainly the probability. So model log predicted dot probability. So here also that same plot, but this won't make much of a sense. But as you can see, this is more concentrated towards the initial part, and this is more towards the later part. So we are expected to get something good here. So now I'm also importing my test data set. So here that startup has provided me all the data set differently, test and train in the different Excel file. So it was good. I don't need to split it. So again, I'm converting all the uh, variables into factor, and now I'm trying to predict with my model. So it was model log dot step. So here I'm making a prediction on the same train data set. I'm trying to see uh, what is the probability I'm getting for it. So it is good to have it tested on the new data set completely, but let me try to do that in the train data set itself, and then let me try to see what is my values that I'm getting. So if I see my train data set now, I've created a new variable probability here, and here let me try to see, and this is now completely on test, so completely on new data set. So there what I was asked to do that I needed to make a prediction on train data set and also on test data set, that how good my classification can work. So for creating ROC curve we have a direct package here in R, ROCR. You can use that, and this is the entire code for creating that ROC curve. This is quite straightforward. So see the lift is not quite high, though I'm getting a lift, but not as good as I would have expected. And when I'm working with test data set, this is my result. So one thing here, uh, uh, in the case study that I got from that startup, I was asked to work on the same data set using logistic regression, or decision tree, and random forest. With all these three algorithms, I was asked to work with and come up with a model which was stable with in all the situations. So here logistic regression, you can see it is stable for training, and the same thing I'm getting for test data set as well. So there's not much difference. But in case of when I was working with that, I would say decision tree and logistic regression, there was a huge difference. And let me show you that, and so that it becomes clear to you as well. Now here I've created the presentation also. So this was it. So using logistic regression, I was getting it. So when you see logistic regression is stable for training and testing dataset both. In decision tree, I was getting a good curve here, good lift in training, but in testing, that lift went down. For random forest, lift was too good, but again it went down. So that's why in the later on I choose logistic regression over other three models, because other two models, because it was more stable throughout. So this is a function to find out uh, what would be my optimum cutoff range. So this is a direct function using which you can predict or you can make a cutoff value. So these are my values. For cutoff, I need to have the value as 0.599, and that will be the correct value to choose, and that will be the best threshold value. Mm, Tough. Okay. So I'm if it is more than that cutoff, then one, otherwise zero. So this is what I have got with the prediction that I did. So predicted value and the actual. So see the kind of misclassification is quite high here. Though classification is also okay, but misclassification is quite high. And if I convert it into percentage, then this was so 67 here percentage good, 64 percentage here. And on total basis, if I look how good is my accuracy, so I've achieved accuracy here of uh, 64% only. So not quite a good model. But what happened is when I was working with all the variables, I achieved a accuracy of some 67%. So mainly you should aim for something more than that. Uh, Something near to 50% is as good as not creating a model at all. You can randomly classify them. Uh, but a classification is considered good if you have somewhat more than 50% or quite more than 50%. And let us try to make that prediction in the test data set as well. And so here the value is quite good, better compared to what I have got in test data set, training data set. So test performs better. But for other cases like in decision tree and random forest, what I was getting is it was inverse. In training data set, my responses were better. But when it comes to uh, test data set, my responses were getting lower. And the classification which I was getting was, uh, quite poor compared to the train. So that's why I've stuck to logistic because it was stable throughout. And this is one of the packages that you can use to plot confusion matrix directly. No need for any mm, uh, functions. For example, I have uh, picked that value of threshold using that function, that cutoff. But in using confusion matrix, you can do it directly. And just you to need to install this carrot package. Could not find error in package. Got it. So finally it got done. So here as you can see, so I have also got my accuracy, my confidence interval, that what should be my range of probability threshold value, p value, whether it is a contributing one or not, and all other uh, parameters as well. So this is for in training data set. For test data set, here also I've got the same thing, accuracy and so percentage. And so and this is a good way to actually work with it. So now let me make a ROC curve finally and try to explain thoughts. So this is my total accuracy on logistic regression, my confusion table, and my ROC curve for training and testing data set. So here are a few more tests that needs to be done after you have made the model. So there are something called Somers Dish test and Hosmer Lehmann show test. So these two I'm assigning to you. I have provided the code here. So uh, just work on this code and you will get the entire set of parameters that you will need, and it will show you that how good is your model. So Somers D test you can try it of your own, and Hosmer Lehmann show test. And these two are the good tests to judging whether your how good is your model is and how well it is performing. So in case if you have an issue, I can get back to you with the entire code for this Somers T test and Lemeshow, Hosmer Lemeshow test. So apart from that, any doubts you can ask me. Okay, then thank you all of you. We will wrap up for today, and next session will be, I think it will be on KNN, K nearest neighbor. So that will be again a classification technique, but there we will have more than two classification or two groups of classification. It could be three or even more than that. So we'll see how it works and what are the techniques there as well. So till then, bye. Meet you next week. Thanks for attending the session today.